Welcome back to The Explainer. I'm so glad you're joining us today because, well, we're going on a bit of a mathematical pursuit. And hey, forget everything you thought you knew about tedious math drills, because today we are playing a game of logic. Our ultimate goal? We're chasing zero. Using a really foundational concept from our source material, we're going to explore how one of the oldest mathematical algorithms in the world turns these messy, unruly calculations into an incredibly satisfying puzzle.
So, how exactly do you tame massive numbers to find out what they share? Imagine you're faced with two incredibly large, intimidating numbers, and you need to find their highest common factor, the HCF. You know, the largest number that divides exactly into both of them without leaving a messy fraction. If you try to just guess or, brute force your way through it, you're going to be there literally all day. But what if there was a guaranteed, step-by-step method to break down those massive numbers into something perfectly manageable? Well, there absolutely is, and it's brilliant.
Okay, let's dive into this. To win this logical game, we use Euclid's division algorithm. It's basically a step-by-step process of repeated division. You take two numbers, and you essentially make them fight it out by dividing the larger one by the smaller one. But here's the secret sauce. You take the remainder of that division, and you use it to divide again and again. You just keep repeating this cascading process with one single relentless focus, which is reducing that remainder until you hit exactly zero.
All right, let's formally meet Euclid's algorithm, the countdown engine.
Before we actually run the numbers, we gotta understand the core mantra that powers this whole engine. It goes like this. Dividend equals divisor multiplied by quotient plus the remainder. So the dividend is the big number we're breaking apart. The divisor is what we're dividing it by. The quotient is how many times it fits, and the remainder is, well, whatever is left over. In our pursuit today, we're going to iterate this exact equation over and over. Each time we run the engine, the old divisor becomes the new dividend, and the old remainder becomes the new divisor. We just keep cranking this engine until our ultimate prize, the remainder, finally hits zero.
Let's kick things off with round 1, 135 versus 225.
Let's actually see this in action. In the left corner, weighing in at 135, and in the right corner, weighing in at 225. Let's run the engine to find out what these two contenders share. Step 1. We start by dividing the larger number, 225, by 135. It goes in exactly one time, leaving us with the remainder of 90. Okay, the remainder isn't zero, so the game continues. We shift everything over. Step 2. Our old divisor, 135, now steps up to be divided by our old remainder, 90. 135 equals 90 times 1 with the remainder of 45. Still not zero. The suspense is kind of building here. Step 3. We shift again. 90 becomes our dividend, and 45 becomes our divisor. How many times does 45 go into 90? Exactly 2 times. And what's our remainder? Zero. We've done it. The countdown engine has arrived at its destination.
And this brilliantly illustrates the magic of the algorithm. The very moment that remainder hits zero, you immediately look at your last divisor. In this case, 45. That is your winner. 45 is the highest common factor of 135 and 225. It's the largest puzzle piece that fits perfectly into both of the numbers.
Moving right along to round 2, the giant. Okay, I think you've definitely got the hang of this, but, that was kind of a lightweight match. This time, we are pitting the relatively small 19.6 against the massive 38,220. When you see a giant like 38,220, your first instinct is probably to panic. You might be setting yourself up for a really long, drawn-out calculation with 5, maybe 6 cascading steps. We're going to have to crank the algorithm engine super hard for this one, right?
Actually, scratch that. It takes exactly one step, just one single calculation to solve this highly intimidating matchup. No way, right?
Check this out. If we follow our algorithm's mantra and divide 38,220 by 196, we find something pretty surprising. 196 goes into 38,220 exactly 195 times, meaning right out of the gate, our remainder is precisely zero. The puzzle is basically over before it even really began.
Because we hit zero instantly on the very first try, our last divisor, which was also our first divisor, is simply 196. And I love this because it proves that you should never let massive numbers intimidate you. Our algorithm handles giants just as easily as it handles the small stuff. 196 is our undisputed giant slayer, and our HCF.
All right, time for round 3, the final boss.
We've got one final challenge left from the source material to test our logical engine one last time, pitting 867 against 255. Let's move to it and see how this builds. Step 1. We set up the equation. 867 divided by 255. It goes in 3 times, leaving a remainder of 102. Not 0, so we shift and continue. Step 2. The 255 gets divided by 102. It fits 2 times, leaving a remainder of 51. The remainder is shrinking. We're definitely getting closer. We shift one more time. Step 3. 102 divided by 51. It goes in exactly 2 times, and boom. Our remainder drops down to that beautiful perfect 0.
And there is that final dopamine hit of completion. Since the remainder is 0, we look at our last acting divisor, which is 51. We have successfully conquered the final boss, and 51 is the highest common factor.
Which brings us to the golden rule, last divisor standing.
So the crucial point here is this. We've played 3 rounds, faced completely different sizes of numbers, and we've successfully chased 0 every single time. In round 1, our HDF was 45. In round 2, it was 196. In round 3, 51. But honestly, the numbers themselves don't matter nearly as much as the underlying logic. The golden rule just never wavers. The last divisor before the remainder becomes 0 is always the highest common factor. It's absolutely bulletproof logic. As long as you follow the steps and keep dividing the divisor by the remainder, the algorithm will confidently guide you to the truth, for sure, every single time.
So, what does this all mean for us? Well, Euclid's algorithm is really a masterclass in breaking down big, complex, and seemingly chaotic problems into small, predictable, iterative steps. If mathematical giants can be tamed just by stubbornly applying a simple set of rules to find the core of what they share, where else can you apply systematic logic to simplify massive problems in your own life? Think about that as you go through your week. Thank you so much for joining me for this explainer. I really hope you found this deep dive into structured logic as empowering and fascinating as I did. Keep learning, keep questioning, and I'll see you next time.